Hey everyone, in this particular video, we're going to be looking at the big ideas for section 3.2, part 2. And it was all about residuals and residual plots. So let's start off with this big idea. And that is just the least squared regression line. Now, there are some other names for the least squared regression line. I don't have them listed in the big ideas, but if you want to write these down, it wouldn't be a bad idea. The least squared regression line can also be called the line of best fit or the linear model. And what is the least squared regression line? Well, it is the line with the smallest sum of the squared residuals. So it's the line that minimizes the residuals. It makes the sum of the residuals squared as small as possible. So that's one of the big ideas. That's why it's called the least squares regression line. So our next big idea is also dealing with residuals, and that is residual plots. So residual plots with a random scatter show that a linear model is appropriate for a distribution. A residual plot with a curve or a pattern or a clumping of points shows a linear model is not appropriate for a distribution. So sometimes students will just look at R, the correlation coefficient, to determine if a linear model is appropriate. You should not be looking at R. It is possible to have an obviously curved distribution, but have an R value that is very close to 1. I was just looking at one the other day that was obviously curved, and yet R was 0.95. So that's very strong. That would indicate a very strong linear relationship. But when you look at the residual plot, there was obviously a curve to it. So the only thing that you should be looking at to determine if a linear model is appropriate is a residual plot. Now, most of the time, residual plots will be given to you, but sometimes you might be asked to create them. It would be for a small set of data. So let's take a look at a few residual plots. So let's just say that each one of these is a residual plot. This first one over here on the left, I would say that this one shows that a linear model is appropriate because there is a random scatter. There's no pattern, there's no curve, there's no clumping of data. Let's look at the one in the middle. Now, this one is one that can be kind of deceptive because when you look at the residual plot, you kind of see that it looks pretty linear, but that's not what we're looking for in a residual plot. In a residual plot, we want, like we see in graph A here, we want points scattered all over the place. So this B, this is showing a pattern. So this is definitely not, or I should say, a linear model would definitely not be appropriate for whatever this distribution is. And then finally, this last one, we see there is definitely a curve to this residual plot. So a linear model would not be appropriate for this original distribution of data. So the first one, residual plot is scattered all over the place. A linear model is appropriate. For the second one and the third one, there is a pattern and there is a curve. A linear model would not be appropriate for the distribution of this data. And that's because these are residual plots. So hopefully this helps you and hopefully you have a great day.